Hello, today we are looking at section 2.3, which is reviewing polynomial division from Algebra 2. So remember that we have our help sheet online. So we're looking at these things right here. They're the definitions that you learned in Algebra 2, and we'll talk more about them today. In the problems that we're going to work out, I have 6 problems here, and they're all worked out in multiple ways. So we're not going to work each one out all the ways every time. But that way, if you were struggling with synthetic division, you could go back and see several questions with the synthetic division on it. If you were struggling with long division, you'll be able to see several examples that have long division instead of just doing one way or the other. So we're going to talk through those, and we're going to talk through the theorems and things that you should have down from your Algebra 2 class. So we're going to look at a few definitions here. So the first thing is the division algorithm, which says if we're taking this polynomial that we called f of x, then that's equal to the divisor times the quotient plus the remainder. And so that's that basic rule of division. You learned about the remainder theorem last year, which says if f of x is divided by x minus k, so if it's divided by this linear function, then the remainder is whatever you get when you plug in the root of k. So like if this was x minus 2, if I plug in f of 2, whatever that is should be my remainder. Then we learned about the factor theorem that says when I'm looking at factors like x minus k, which might be linear there, it is a factor only if that remainder equals 0. So if the remainder equals 0, then this binomial would divide in there evenly. And then we learned about the rational zero root test, and we abbreviate that RZT, and that is all possible rational zeros. Remember, rational number is something that can be written in the form of a fraction. So this is a test that looks like a fraction, and you take all of the factors of the constant term, that would be the plus and the minuses, and then you divide that by the factors of the leading coefficient. And then we also learned that we have 2 different types of division. We have long division, which works for all polynomials, no matter what the divisor looks like. And then we have synthetic division, which is a shortcut using only the coefficients, and it only works, or is best to only use it when your divisor is linear and a is 1, and that's going to be your best time to use synthetic division. So remember that long division is a process of multiplication and subtraction, where synthetic division is a process of multiplication and addition. The first problem we're looking at is this polynomial 6x cubed minus 9x squared plus 16x minus 4, and we're going to divide that by x minus 2. And so we're going to write the quotient to the factor of the polynomial. So a couple of things here when you're looking at this problem. If this is factor form, when I solve it for x, then I have the root, right? And that's what the theorem uses. So it says if I take 2 and plug it into my function f, and I look at the remainder, if the remainder is 0, it's a factor. If the remainder is not 0, then it's not a factor. It doesn't divide in there evenly. So since I plugged it in and did the math and got f of 2 equals 0, what I know then is x minus 2 is a factor of this polynomial, meaning that it's going to divide in there evenly. So working this out with long division first, I put the dividend underneath, I put the divisor out front. This is what I'm dividing by. And I could do this in synthetic, and in fact I did do it over here in synthetic because it's a linear and a is 1. So you have to think what times x gives you this number underneath. And so I know 6x squared times x would give me 6x cubed. Remember, when you multiply like bases, you add the exponents. So that's a power of 2 and a power of 1 gives me that power of 3. But then you have to also take that number you put up here and multiply it through. So I take 6x squared times x and I get 6x cubed. I take 6x squared times negative 2, I get negative 12x squared. But remember, we talked about long division as a process of multiplication and subtraction. So what's happening here at this step is going to be subtracted. It's minus 6x cubed and it's minus a negative 12x squared. So what I'm doing is actually subtracting 6x cubed, but I'm adding 12x squared. So if I did this right, these 2 first numbers should eliminate. And the reason they should eliminate is division is a process of breaking it down. So that means it should be getting smaller. So I'm getting rid of the x cubed. I have negative 19x squared and positive 12x squared. So the difference between that is negative 7x squared. And I bring down the next term in my dividend. So now I think what times x gives me negative 7x squared, and that's going to be negative 7x. And then I multiply through. Negative 7x times the x gives me negative 7x squared. Negative 7x times negative 2 gives me positive 14x. And because I am subtracting this entire line, that means I'm multiplying through by a negative number. So that means these two things are going to eliminate, which is what I wanted. Well, these two things eliminate now here, which is what I wanted. And then I have 16x minus 14x, which leaves me a positive 2x, and I bring the number down to the next line. So one more time, what times x gives me 2x, and that's a positive 2. So 2 times x gives me 2x. 2 times negative 2 gives me negative 4. And remember, I'm subtracting the whole line. So that means I'm multiplying through by negative 1, which changes all of the signs. And luckily for me, then my first terms still eliminate, but also my second terms eliminate, leaving me a remainder of 0, which is what I wanted to get to begin with. Because remember, we checked it before we started over here, so we knew we should get the 0. So if we go to the next method that we're talking about, that's synthetic division. And when we do synthetic division, we don't use any of the x's. So when I'm working through a synthetic division problem, I need to check my original polynomial. Do you see that I have a power of 3, a power of 2, a power of 1, and a number? That means I have every power from 3 all the way down to that constant term. And that's what I want. If I'm missing any powers, for instance, if I were missing this one right here, then I would have to include a 0 in that place in my synthetic division because the number has to hold its place. And without those letters there to do it for us, we have to be very careful. So when I come over here to synthetic division, I take all the coefficients, the 6, the negative 19, the positive 16, and the negative 4, and those are what these numbers represent. This is the root, so remember, I am doing x minus 2 equals 0. That's the factor. The root is x equals 2, and so that's what I'm dividing by. Some of your Algebra 2 teachers may have just drawn a straight line down here. I tend to use the backward box. I don't care which way you do it. However you learned it is totally fine with me. Just make sure you've got everything in the right spot. So notice no missing powers, so there's no zeros that are needed. I bring the first number down below the line, and remember, synthetic division is a process of multiplying and adding. So anything that's below the line gets multiplied, anything that's above the line gets added together. So we bring that first 6 down, and I'm multiplying them by that 2 right there. So 2 times 6 is 12, and you put that right above in the next column. And then now we're above the line, so we add. Negative 19 and 12 gives me negative 7. Well, since you're below the line, you multiply. So negative 7 times 2 is negative 14. Above the line, you add. So 16 and negative 14 is positive 2. And below the line, you multiply. 2 times 2 is 4. Negative 4 and 4 is 0. So what this back number is in synthetic is the remainder, and then you work your way back up in order. So then the next thing to it would be the constant, and the next thing to it would be x, and the next thing to it would be x squared. And when I say next thing to it, I just mean so you don't skip anything here. And what you're doing is identifying these coefficients that go with these letters. So then my quotient becomes 6x squared minus 7x plus 2. And that's the quotient for this problem. And that's what we got here. Now, if you get to the point where you get to this point right here and you're trying to break it down, I can look right here and I can see that this is a factorable trinomial. We should be really good at factoring by now. And so it factors to 2x minus 1, 3x minus 2, and 2x. So if it asked me for a factored form, this would be what I would be looking for. And so what we do is we use the division techniques to break this down to hopefully to a form that's factorable. Then I can stop using the division as a tool for factoring and just do my good old-fashioned factoring techniques and come up with the factorization. And then if I wanted factorization, here you go. And if I'd wanted roots, then I would say x equals 2, x equals 1/2, and x equals positive 2/3. In problem 2, we're being asked to take a cubic, a difference of cubes, and divide it by an x minus 1 linear factor. So we have actually worked this problem earlier in the year. We would factor this to get x minus 1 times x squared plus x plus 1, because we should have our factoring with sum and difference of cubes down really well by now. And then we would have x minus 1 on the bottom of this, and because everything is a factor, then I could cancel the x minus 1's and I'm left with x squared plus x plus 1. If it just said to find the quotient or find the rule, then you could do that. It does say divide, so we're going to play this out and look at what it would look like in long division and synthetic. All right, so in this case, notice there's an x cubed, but there's no x squared, there's no x, and now there's a number. So typically when I set up a problem like this, I'm going to leave some blank space in here so that when I'm going through my division problem, if I end up with like a power of 2 or a power of 1, I'm going to be able to make its own column. One of the biggest mistakes I see in problems like this is students not leaving space, and then all of a sudden the x squared comes under the x cubed, and now you've got some interesting powers trying to add them together that shouldn't be added together. All right, so what times x gives me x cubed? That would be x squared. And don't forget, you have to multiply by the whole binomial, so x squared times 1 is x squared. Then you're subtracting the whole line, so that's changing the signs, and our first term goes away like we wanted it to, and we're left with an x squared. And then we do it again. X times what is x squared? Well, that's going to be that x right there. And then multiply it through the whole binomial. X times x is x squared. X times negative 1 is negative x, and then we subtract the whole line. So the signs change, and then these two are going to eliminate, and I'm left with an x. Okay, I'm down to my x, and so I'm going to bring my 1 minus 1 down at this point and do the whole thing again. What times x gives me x? 1 times x gives me x. 1 times negative 1 gives me negative 1. And because I'm subtracting the whole line, now the signs change, and I can see that both of these are going to eliminate to begin with. Well, I should have known that if I checked. Remember, if we use that remainder theorem, so we put a 1 in there, because remember, this is the factor, but the root would be 1, and I plugged 1 in and I got 0. So I know that when I get to the end of my division problem, that should be 0. And we know that f of 1 equal to 0 means that x minus 1 is a factor. Okay? So if I did it in synthetic division, so I would take the 1 and I put the 1 here. And remember, they're missing power of 2 and the power of 1. So I have a 1 for the x cubed, I have a 0 for the x squared, I have a 0 for the x, and then I have a negative 1. Anything that's missing, remember, we need to make sure that we have the placeholders. Okay? So now we're here, and we bring, that's what we're dividing by. That comes from the divisor. And then this is the dividend stuff with the zeros to hold the place. So you drop the first number down below. You multiply when you're below, write your answer up above. You add when you're above, write your answer below. You multiply when you're below, write your answer above. You add when you're above, write your answer down below. You multiply when you're below, bring it up here. Negative 1 and 1 gives me a 0, which is what I wanted it to do since I'd already tested that value. So there's my remainder, my constant, my x, and my x squared. So the quotient, x squared plus x plus 1, or the quotient, x squared plus x plus 1. And when we factored, what did we get a minute ago? X squared plus x plus 1. Okay, so that's the quotient. All right, problem 3. So we're dividing this polynomial right here, and we're dividing it by this. So we should be able to look and see right off the bat that you can't use synthetic for this one because this is a quadratic divisor. So this is what goes on the outside. This is what goes underneath. Remember, when you multiply through, you have to multiply through to all 3 terms. All right, so what times x gives me 2x to the 4th? 2x to the 4th. 2x times 2x squared times x squared that's giving me my 2x to the 4th. 2x squared times 2x gives me 4x cubed. And 2x squared times negative 3 gives me negative 6x squared. And then remember, this is subtraction, so this whole line is being subtracted, multiplied through by negative 1, flips all of the signs. And I can see that the first 2 are going to cancel away and leave me with a positive 6x squared and a negative 5x squared, so that's just x squared. And then I'm going to bring down the rest of my numbers. Okay, and then I'm going to try again. So what times x squared gives me x squared? And it has to be a 1. So then remember, you multiply through by all three things. 1 times x squared gives me x squared. 1 times 2x gives me 2x. 1 times 3 gives me 3. Subtracting the whole line changes all the signs, and this is going to eliminate. So I'm left with a positive x from this, and I'm left with a positive 3 minus 2, so that's going to give me a 1 there. Now, that one didn't divide out evenly, right? So how do you write your answer when you have a remainder? Well, you take your quotient, which you got up here on the top, and you add, always add. And then you take the remainder over the divisor, and that's what it looks like. So you have a fractional part of that polynomial. It's very important you remember to always put a plus. Sometimes students will do this and they'll see like negative x plus 1 and they'll go, oh, well, I'm going to make that subtraction. So then they bring the subtraction down, but then they still put x plus 1. Right? That negative only went to the x, so that would not be good math to use because you would be incorrect there. On question 4, we're dividing this by x plus 3. So we know that if we do x equals negative 3, we can plug it in. And so what I found is when I plugged in negative 3, I got a 1. So that tells me that x plus 3 is not a factor of this, which tells me I should have a remainder for my quotient as part of my quotient when I do the division. Okay, so if I do long division, here is my divisor out here. Here is my dividend, which goes underneath. Notice that I don't have a power of 3, so I left a little space in case a power of 3 crops up in my division. So what times x gives me x to the 4th? X cubed. X cubed times x gives me x to the 4th. X cubed times 3 gives me 3x cubed. So you can see that place opened up. And now I have it in its own column, so I'm not likely to make the most common mistake of putting it together with something it doesn't belong with. Then I'm subtracting this line, so I change my sign, so my x to the 4's cancel out, and I'm left with negative 3x squared. And I bring down the next term. So then I have to think, what times x gives me negative 3x cubed? And so I have a negative 3x cubed. So negative 3x cubed times x gives you negative 3x cubed. Negative 3x squared times 3 gives me negative 9x squared. And it's subtraction, so I'm changing my sign. So my opposites eliminate this, and I'm left with negative x squared. And then I bring down my 2x and do it all again. What times x gives me negative x squared? X squared, or it gives me x, right? So x times x gives me x squared. X times 3 gives me negative 3x. We change the sign because we multiply everything through, and then when we put it together, I have positive 3x, negative 2x, which gives me 1 positive x. And I bring down the number. One last time. What times x gives me x? Well, that has to be 1. So 1 times x gives me x. 1 times 3 gives me 3. Subtracting the whole line means the signs change, and I get a negative negative. So this one eliminates, and this one leaves me a remainder of 1. Okay, so what does that mean? That means that my answer isn't going to just be a quotient that's a nice factor. It's going to have that remainder piece to it. So here's the quotient, which I got from the top, and then the remainder was 1, and the divisor was x plus 3, and that's what my remainder is going to look like. If we'd want to do the problem in synthetic, I went ahead and included that, but you can see you get down to the same place. You get x cubed, negative 3x squared, minus x, plus 1. So when you're doing that, keep in mind where your variables are. Do you need a 0 to hold a place? All that fun stuff. So my quotient is everything up here in the top, which is right here, plus, because we're always going to use a plus, the remainder, which is 1, over the divisor, which is x plus 3. And that's what that fractional response would look like. So now we're going to talk about the rational zero test. The rational zero test is a set designed to create all possible rational zeros. Remember, a rational is something that can be written in the form of a fraction. And all possible means everyone that could potentially be a solution. That doesn't mean that every one of them is a solution. So you do have to test for values. But basically the rule is that factors of the constant term and the factors of the leading coefficient. And this one's referring back to 3. So let's look at problem 3 one more time. So the leading coefficient is what's in front. The factors are what's in back. Okay? And so that's what's going on here. The factors, the constant was 2, the leading coefficient was 2, so I do plus or minus 1 plus or minus 2 divided by plus or minus 1 plus or minus 2. And so what that means is we're going to have 6 possibilities. And I would expect to see this on your paper for anything where the leading coefficient is bigger than 1. So then I would do 1 divided by 1, 2 divided by 1, 1 divided by 2, and that should take care of it, because 2 divided by 2 I would have already had. So these are the 6 possibilities. That means if there is a rational solution, then it's going to be in one of those 6 places. Okay, so if I look at 4, which we just did a moment ago, my constant is 4. My leading coefficient is 1. So constant is 4, leading coefficient is 1. And I get plus or minus 1, plus or minus 2, plus or minus 4. On the bottom, I get plus or minus 1. So everything is over 1, which means I can just list them out as they are. It's possible 6 rationals. Okay, I hope you understand the difference. So one more time, if there's more than one factor for the leading coefficient, then I need to see the fraction that you set up using the RZT, the rational zero test, and what the possible rational zeros are. That is an expectation that it will be in your work. Okay? If it's a 1 on the bottom, then I don't need to see this. You can just go straight to your list. So I just want to make sure you're clear on that. In this particular problem, it's asking us to show that x minus 2 and x plus 3 are factors of this polynomial. Then find the remaining factors. So for it to be a factor of this polynomial, it should come from the rational root test. So that's where you're getting these values. Now this is x minus 2, so it would also be x equals 2. And this is x plus 3, so it would also be x minus 3. All right, so the first thing you would do is write your rational root test. And so all of the factors of the constant were 1, 2, 3, 6, 9, 18. And all the factors that were left were 1 and 2. So then everything on the top goes over 1, and then you look at everything on the top in relationship to 2. So 1 over 2 is 1/2, and that's now in our list. 2 over 2 is already there, so I don't have to worry about it. 3 over 2 is now in our list. 6 over 2 is 3. 9 over 2 is now in our list, and 18 over 2 would just be 9. So that's where my list comes from, and this is the list of all possible zeros. Okay? Once I know those, then I can start checking to find my answer. So I could plug in 1 and see what I got. I could plug in -1 and see what I got. I plugged in 2, and so 2 cubed is 16 times 2 is 32. I'm sorry, to the 4th. 2 cubed is 8 times 7 is 56, and so on. So you can kind of see how that plays out. And then when I put all those numbers together, I got a 0. So that's good. Now remember, that's showing 2 as a factor. We do the same thing with 3, but I'm going to break it down with 2 right now since we just showed that there. So 2 goes in my box because I'm going to use synthetic whenever I can because it's just faster and easier. And then I'm going to bring the 2 and drop it straight down. And then I multiply on the bottom to get 4, add to get 11, multiply. 2 times 18 is 36, and then add to get below, and then multiply at the top, and then add to get below. So I have my remainder, my constant, my x, my coefficient of x squared, and my coefficient of x cubed. So now I have broken it down to here. So this was what I divided by. This was the quotient that I got that divided out evenly. All right. But now remember the question said show x of 3. Sorry about that. I moved that too far. Show x of 3. So all we did was show x, the factor x minus 2 has a root there. All right, so I'm testing -3. I plug it in. I get a 0. Woohoo! So now I know it's true, and I can actually do the division to take care of that. So I go back to my synthetic. I make that -3. There are no missing powers here because this is where I'm working at right now. And I would do 2, 11, 18, 9. So bring the first term down, multiply below, that's -6, and bring it up. 11 and -6 is 5. 3 times 5 is -15. 18 minus 15 equals 3. And then 3 times -3 is -3. 9 plus 9 gives you 0. So the advantage to that right now is we can just factor that again, right? So now we have a factor of x plus 3, and we have a factor of 2x squared plus 5x plus 3. So here's what my factorization looks like. Don't forget the x minus 2 from the beginning. Don't forget the x minus 3 of the divisor. That's what we were dividing by. And then don't forget the quotient that you got down here. So once I get down here and I see it's a normal trinomial, then I want to see if I can factor, because if I can factor, then I don't have to use the division anymore. Okay, if I couldn't factor, then you could use your rational root test again on this, find numbers to plug in until you found a 0 and go from there. Luckily for us, this is factorable. So actually when I get down here, this factors to x plus 1, 2x plus 3. So remember last time we talked about if it was in factor form, we could check the degree. So that's 1, 2, 3, 4 when we add them up. And if we look at the problem in the beginning, it had a degree of 4, which means I should have 4 answers. And that could be a combination of complex and imaginary to all being real, or they're a combination of both. So this question asks for the roots. You would give the answer like this, not like this. Factors, roots. You've got to know the difference. Notice all 3 roots are in the rational, all of the roots are in the rational 0 test, and that we listed out at the start of the problem, right? So 2, -3, 1, and -3/2, and they're all in this list right here. Okay, so that takes care of question 5. Question 6 is just a little bit more practice using the RZT test. And so question A gave me this, and it wants us to find the zeros, the rational zeros. Okay, so I know that the constant term is 1, the leading coefficient is 1, so really all of my answers in my RZT test are just plus or minus 1, so that's pretty easy to check. So if I do the f of 1, I get 3 when I plug it in. When I do the f of -1, I get -1 when I plug it in. And so what that means is I have an interval from 3 to -1 going on the x values from -1 to 1. Well, we know that by IVT, this guarantees if my y values change from positive to negative, that I have to have a 0 somewhere between these two. And so by knowing that, then we know that if there's a root between these two, and it's not either one of the only 2 that I have in my rational 0 test, then I know there's no rational zeros. So you have to be careful. Don't say no solution, no whatever. Say no rational solutions, because there could definitely be imaginary ones. On B, so here's what I have, my rational root test. I did plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Leading coefficient is 1, so that's just plus or minus 1. So then I started plugging in numbers. So when I plugged in 1 into this equation, I got -8. That doesn't work. When I plugged in -1 to this equation, I got 0. So I know this is something I can factor because it's going to go in evenly, and that's what I did using synthetic division. So remember, the x value is -1. That's the root, so that's what you're dividing by. The powers are 4, 3, 2, 1, 0, so nothing's been left out, so you don't need any zeros in your synthetic division. The coefficients are 1, -1, 1, -3, and -6, and that's what I have laid out right here. So bring the first one down. -1 times 1 is -1. Add them when it's above, you get -2. -1 times -1 is +2. Add them when they're above, you get 3. -1 times 3 is -3. Add them when you're in above, you get -6. And then when you do -1 times -6, you get 6. And -6 and +6 is 0. So there is that remainder. Remainder, constant, x squared, x cubed. So remember we divided by x plus 1, so that's what that is. And then here's my quotient, so 1x squared minus 2x squared plus 3x minus 6. And that's what you see right there. And this is a 4 term that can actually be completed by grouping. So I can pull out an x squared from the first two, and that gives me that. I can pull out a 2 from the next one, and so I have x minus 2, so that comes out as a factor here, and I'm left with x squared plus 3. So as I'm looking at this, when I look at this, right, what happens when I set this equal to 0? I move the 3 to the other side, it becomes negative, and so now I'm taking the square root of a negative number, which means I have an imaginary number, not a rational. So I ended up in this case with 2 rational solutions and 1 imaginary, and if you notice from our RZT test, both of those rational roots are in this list. So the rational roots would be x equals -1, x equals 2. Pay attention to your notation. Remember, roots, zeros, solutions, we write as x equals, x-intercepts, y-intercepts, we write as coordinate points, and we don't include this in the rationals, so you're only going to see 2 of the 3 roots there, but all together, 1 plus 1 plus 1 is 3. That's the degree, so I have accounted for all possible solutions. We are almost finished, so let's look at C. So again, the constant term is plus or minus 1, plus or minus 3. That's what's on top. And the leading coefficient is 2, so plus or minus 1, plus or minus 2. So then I can do my division, 1 over 1, 3 over 1, 1 over 2, 3 over 2. So here's my list. Notice your fraction is here and then the list. And because it didn't say divide with x minus 2 or divide with x plus 3, I've got to use that rational zero test to find the numbers to work with. So then I started plugging them in. So I plugged in a -1 and I got 12. That's not a factor. I plugged in a -3 and got 0. That is a factor. So that's what I use in my synthetic division. So notice there's a 3, 2, 1, 0. So all powers are accounted for. So I don't need any placeholders. Bring the 2 all the way down below the line. -3 times 2 is -6. 3 plus -6 is -3. -3 times -3 is 9. +9 and -8 is +1. 1 times -3 is -3. 3 plus -3 is 0. So remember, this is the remainder. And okay, so let me backtrack here because I realized I had a little mistake there that I went ahead and fixed. So this is the remainder. Here's the constant. Here's the x squared. So then what's going to happen is we factored by an x plus 3, so that's one factor. And here's the quotient, which is the other factor. And then now I have a trinomial that's factorable, and I can just break down the trinomial with my traditional factoring. I have 3 factors, but the rational zeros are x equals -3, x equals 1, and x equals 1/2, all 3 of which are in this list up here. All right, guys, last one. So if we have this and we're trying to break it down, then we do the rational zero test. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. The leading coefficient is 1, so that's just plus or minus 1. So from my list, then I start finding a 0 to divide by. So I plugged in 1 and I got -12. Definitely doesn't work. I plugged in a -1 and got 0, which does work. So then I'm going to use this to divide with. Now you might have found a different one to divide with first, and that's okay. As long as you get this 0, then you're good to go with the division. So again, back to my synthetic, the x is -1, so that's what I put here. I need a 0 placeholder for x squared, so I've got that right there. So I have power of 3, power of 2, power of 1 constant. Bring the 1 below the line, and away we go. -1 times 1 is -1, 0 and -1 is -1. -1 and -1 is +1, -7 and +1 is -6, -1 and -6 give me +6, -6 and 6 give me 0. So then I have my remainder, my constant, my x, and my x squared. So this is one factor, so that's what I have the x plus 1 for, and this is the quotient, which is my other factor, which is 1x squared minus 1x minus 6. This is a trinomial that can be factored, so I can break it down into factors, and then I can get my rational roots. X equals negative 1 from here, x equals 3 from here, and x equals negative 2 from there. And that's the rational zeros, again, all of which are in this list. So that's the basic process. If this wasn't factorable, then you might need to recreate another RZT test to get some numbers to divide by. So there can be some different things going there. But remember, we're using the division as a factoring tool. And as soon as we get to something where we can just factor it all, then that's when we stop using the division, and that's when we start working with just factoring techniques to break this down. So you will have your assignment on Canvas over polynomial division, and be sure and come in with questions if you have them. Thanks, guys.